teacher and the world-renowned educator, software developer, the coach, the consultant, the author, the absolute rock star. And I hope, my friend, today we have a session by Venkat Subramaniam. I don't know if Venkat needs any more introductions. He is a superstar, and it is always a pleasure to meet you, Venkat. How are you doing?
Very well. Thank you so much. I really appreciate you having me here, and thanks everyone for joining as well.
Very good. We also have Graeme Rocher here on the stream, because today's session is about building cloud-native applications with Micronaut and GraalVM. He's currently with us in voice and spirit. Graeme, would you like to say a couple of words as well?
Yes, hello. Hello, everybody. I am super ecstatic and excited about this. So looking forward to it and can't wait. Love event presentations. So, and known each other for a long time, and it's great to see that come out on the stream. It's an awesome day.
A quick question to you, Graeme, immediately. Would you expect to learn something from the session, or do you think you know everything there is about Micronaut?
I'm a forever learner, and I think there's every time there's something you learn, something new every day. I think that Venkat has some amazing magic when it comes to live coding, and yeah, for sure, I think just from that I'm going to learn a whole bunch.
Absolutely. I would absolutely learn. I know I will learn some things. Right. Okay, then this is the part one of this webinar, so to speak. So we're going to cover several things. There is a lot of on the agenda. And then if you're watching this later on YouTube, be sure to check out whether the part 2 has already aired as well. It is currently scheduled at approximately 2 weeks from now. So if it is aired, go check out that video as well. And if it's not aired, well, mark your calendars and join us live next time. All right, without further ado, Venkat, how are we going to do this? Are we going to share your screen and let you take the stage?
Awesome. Thank you so much. I'm sharing my screen, so let's make sure that's visible to the audience. First of all, I want to start by saying I couldn't ask for better. We have the creator of the technology here, Graeme, with us, and of course on GraalVM we have Oleg, who can depend on for a lot of insight. So this is going to be a joint presentation where I'm going to show the technology, talk a little bit about it. But please do ask questions along the way. Anytime you have a question or a comment, post them on the links that you have available. And among the three of us, one of us will answer right away, as and when you're asking the question. We can take some questions towards the end, but we would rather take as many questions as possible along the way. So let's make it as interactive as we can. Again, thank you so much for taking your time to join. I do have to start by saying, I just don't enjoy using Micronaut. I love using Micronaut. Part of the reason I love using Micronaut is I really like technologies that simply get out of my way. That is what I feel about Micronaut. It's a technology that gets out of the way. It focuses on letting me do my work and implement the technology, implement the solution that I'm really hoping for. And a lot of things that just fall in place. And that's what I'm going to show you today. Well, in the part one today, we're going to talk about Micronaut. We're going to talk about building application with it. We'll deploy it on the JVM towards the end. We'll also deploy it on GraalVM as well. And we will look at the runtime performance. We'll look at the startup time it takes. We'll take a look at the time for the first request. We'll also take the time for subsequent requests as well. So we can get a feel for the time the technology takes along the way and why we should maybe choose one versus the other. And embarrassingly, almost no effort to really achieve that. That's the interesting part about it. The only thing you have to remember is never tell your boss that it's that simple. Tell them it takes a lot of time, a lot of effort, get it done and go do other fun things in life. So that's what I'm going to show you here is how cool the technology is, how we can build with it. Now, before we get into the coding part, I want to spend a few minutes talking about things. Now, the world we live in, I started programming about 35 or so years ago. And we've come a long way since then in terms of the types of applications we build. And in all fairness, even Java has taken the journey from the days when Java was started to what technologies and expectations the business has. So today we live in the world of predominantly, among other things, of course, the microservices world and the world of serverless computing. And in each of those, you could say there are certain demands we can say are common between them. And what are some of those demands? Well, first of all, we want developer productivity, but we also want the productivity of the application or the performance of the application as the application executes. And I'm a huge fan of not compromising one forgetting the other. You may see some technologies which are easy to build, but don't really perform really well in production. And I don't need to name them because we all know what those are. Then, of course, there are technologies that are really hard to build, squeezes every ounce of your energy, but performs really well. And we also know what those technologies are. Micronaut is something that brings those desires together. It's easy to build with, so we can be productive as developers, but also gives us performance at runtime. That's a wonderful combination we can expect. Microservices and serverless computing demand fast startup times in general. Serverless a lot more than microservices, but we can say that's definitely needed. They also need smaller footprint, both in terms of the deployment and runtime as well. And of course, the runtime performance, one thing startup and running, how much time and effort does it take to respond to requests? That's important as well. So where can we squeeze out performance? Or in other words, where are the performance degradation come in? Where do we use more memory? Where do we use more runtime? Well, that's exactly what has gone into Micronaut to figure these out. Now, some of you may have used, or a lot of you may have used technologies like Grails in the past. I was one of the big fans of Grails back in time. And over time, of course, while Grails is one of those technologies that give us a lot of developer productivity, there are things we often wonder about. What about performance? Well, Micronaut was developed from the ground up with the intention of bringing performance to the table. And so that's one of the design criteria. But of course, we also live in a polyglot world today. And of course, we want to be able to build the solution with different technologies. As you know, microservice itself is, to a great extent, language agnostic. You can build microservices using any technology you want. But if you do choose to program with Micronaut, what are your options? You could build with Java, you could build with Groovy, you could build with Kotlin, and Kotlin actually shines really well with Micronaut as well. And I think there's also efforts towards building with Scala as well. I'm going to let Graeme chime in for a minute about what are the scope we can expect in terms of Scala. Is that imminent? What are your thoughts, Graeme?
So it's not, I would say, imminent. One of the things we actually have to deal with soon is, in fact, Kotlin related, because the Kotlin, I believe, is moving from away from CAPS towards to another technology called KSP, which is Kotlin symbol processing. So it may be that we have to actually rewrite the Kotlin Micronaut very soon. And that will likely need to be combined, the effort, with whatever we do with Scala, because we have to essentially support a new language AST to support Scala. So we have a proof of concept actually done with Scala, and it does like simple cases, but it still needs a lot of more time in the oven, basically.
Thank you. Awesome. More time in the oven. I love that. So one of the beautiful things about Micronaut, you're going to see this quite a bit in my presentation today, is the fastest startup time. So you're compromising just a little bit on compilation time, not too significant in my opinion, but one of the key things is that you're not going to be running into reflection at runtime. So it's compile time meta programming. I'm a big fan of meta programming, but if I can have meta programming at compile time, that's even better. And that's one of the nice things about Micronaut. And we're going to see this quite a bit along along the way. It's a technology that uses high throughput, a very small memory footprint overall in terms of at runtime, and also the amount of space it's going to take with the files itself once you bundle them up. Like I mentioned earlier, one of the things I really enjoy about Micronaut is where things just work. And if you want to modify things, you can annotate your way or write configurations, but from the ground up, you don't have to do too much of that. Things just work. And this kind of comes back to what I always look for as sensible defaults. And when things just work the way they're supposed to work, we're not spending a lot of time and effort in a configuration hell. And with other technologies, that's what one of the things annoys me is if I want something to work, I got to spend the next 15 minutes figuring out how do I configure what annotations I should use. I don't have to do that with Micronaut. Simply things just fall in place and work. And even when I do have to configure, it's pretty easy to find what I need to do. So with that said, one of the key differences between Micronaut and a lot of other technologies is dependency injection, but with compile time meta programming instead of using reflection at runtime. So you get not only sensible compilation errors rather than runtime errors, but you also rely upon the speed of execution because at runtime, it's not exploring what to really bring in. Reflection, is used very extensively, no doubt about it. But at the end of the day, reflection does have a cost. And if it really scale is something that's relative, and if you're competing to really have really fast startup, really fast performance, you don't want to be spending time on gathering all that information for reflection at runtime and then deciphering and executing it. Well, if you're able to generate the code, that's going to give you a lot of good performance. But of course, you and I don't want to compromise that by saying we're going to write a lot of code because that brings us, our productivity down. And this is where Micronaut nicely comes in. Micronaut figures out what you're expecting, but rather than pushing that detail to the runtime, they compile that into bytecode at compile time, and then the code just executes like you and I handcrafted all that code. We're going to take a look at that later on and see where that bytecode is generated, and we can get a glimpse of it. And of course, with this, you can build different types of applications, and you can build conventional applications. You can also build reactive applications as well. That's another thing I'm going to show you today is how we can take this and make it reactive, again, with embarrassingly almost no effort at all. So with that said, what are some of the benefits of using Micronaut? Well, to me, it's the speed of development, deployment, startup, and execution. So you get the benefit in all the 4 different areas. I am productive as a programmer. I can deploy it really easily. It starts up wicked quickly. And of course, at execution time. So it's not just one side wins. It's that overall victory in every single front, if you will. That's one of the benefits we get out of that. It's a small footprint, like I mentioned earlier. It's very declarative in nature. I'm a big fan of writing code that is concise and expressive, and I don't want to be spending too much time and effort writing a lot of code, and that's where this really shines as well. And of course, I mentioned this compile time dependency injection. You can create this for native cloud native interfaces as well. We'll see a little bit more about this in the part 2, though we'll look a little bit about that today as well. And then of course, there are built-in circuit breakers. Definitely I'll dive into that in part 2. That's one of my favorites as well when it comes to building microservices and like I said, compile time meta programming. Well, enough talking. Let's dive in and take a look at some code examples and see how we are going to do this. I don't have anything under my sleeves. I'm going to be writing this code. And of course, along the way, we'll run into some issues, some of them intentional, some of them not, but I won't tell you which one is which. And of course, we'll learn from these experiences and work through. So let's start with a little service we want to start with. Well, first of all, if you have installed Micronaut, from the command line, you could use the command mn, and I'm going to simply say help right here and just take a look at what it provides for us. And notice in this case, it tells us the type of applications we can actually build. You can create a Micronaut application like you normally create a RESTful service, for example. You can create a CLI application, a command line application if you want to. You can build an application function as a service, and then so on. And so there are these options right off the box. Micronaut doesn't go out and create a lot of files for you. It's pretty minimum. And by default, it uses Gradle. I'm a huge fan of Gradle. That's what I use most of the time. Or if you want to use Maven, you can definitely use Maven as well. It's entirely up to you. You're not going to get anything different whether you use Maven versus Gradle. You can achieve the same results with both of those, if you will. So with that said, what do I do here? I have an empty directory, and I'm going to say mn. I'll say create app, and I could simply say stock info to create a stock info application. But I'm a pretty lazy person. If you look in the dictionary, the word lazy, my photo actually is there. So I don't want to do any extra work I can avoid doing. So I'm going to be doing a little bit more work here. And there's a little trick I often follow, which is I'm going to provide a package name, if you will. So in this case, I'm going to say com.agiledeveloper. And I'm going to say stock info. And then I'm going to simply say, in this case, info. And then I'll just call it as a stock info. So in this case, what I've done is I've kind of hinted to this tool, hey, why don't you do me a favor? Use that as a package name for me, so I don't have to really sit there and keep typing that away. So it just saves me a little bit of effort. So I don't have to sit there and create this directory structure in the IDE. Like I said, I'm pretty lazy. I'm just going to run off of that. So when I run that code, you can see that was pretty wicked fast already, as you can see. And when you look at what it created, it was just a stock info directory, right? That's all it created. But if you look at the stock info directory and look in the source directory, what you notice here under the main, for example, is the Java. And as you expect, right, there is a directory structure it created for you automatically. So I don't have to waste my time and effort creating that at that point. So that's all we did. We created a little application right there. Now, all I'm going to do is just fire it up. So I'm going to simply go to the directory stock info, and I'm going to run IDEA, IntelliJ IDEA I want to use here. And I'm going to say IDEA and just fire up that build.gradle file, or a Maven file if you had used Maven option to create it, and you can pull that up. So I'm going to simply say, yep, open up the project for me. And you can see that it's opening up the project file. While it's loading up, let me just go ahead and put this in the background here. So I do have access to the command prompt if I want to. So right there, it opened up the project, not a whole lot right now. And the only thing you notice in here right now are two files that were created for you, which is the application file that you see right here, which is the startup, the main for this application right there. And then, of course, you also see a little test file sitting in there. And this is one of the other things I want to really quickly mention. I'm a big fan of writing automated tests. If you've heard me speak before, you probably know how annoying I become with emphasis on needing to test. Well, Micronaut, and I'm really a big fan of technologies like this. It's not some, where the technology says, testing is really a good idea, you should do it. Well, they believe in the principle of testing so much that they provide everything that's needed and have no excuses left to be given. So if we choose not to write automated testing, we can't blame it on the tool or the technology. So it's really about making it just not only possible, but making it extremely easy as well. So from the ground up, it's a technology built for testing. We're going to see what that is in a few minutes and see how we can write the test along the way. So without writing any code, I'm just going to execute that right now because I'm a big fan of knowing that things just work as we start running. You can see it started up, it executes it, and I'm going to just stop it right now. We'll come back and continue with that in just a few minutes. So what do we do next? Well, the next step here is to start writing some code. And with any technology, we want to write code in a way it's easier to understand, easier to maintain as well. So what I'm going to do here is to go to this directory here, and I'm going to say I want to create a Java class, and I'll call it as a stock, let's call it as a stock class. That's all I'm going to call it. So here is the stock class I created. And what do I want within the stock class? Well, within the stock class, I'm going to go ahead and provide, in this case, the details about the stock itself. And it's going to contain some really, really simple information. And I'm not going to do anything more than what we need to do right now. Let things fail, and we'll come back and deal with it later on. So right now, what I'm going to do is to say private, let's say string, and I'm going to say ticker, and I'm going to create a private, let's say int price, and we'll just keep a whole number for the prices right now. So in this case, I'm going to go ahead and create a constructor with those two arguments right in there. But I'm also going to go ahead and create a getter and a setter for those two properties as well, or the fields rather. So let's go ahead and create for those two and ask it to create a getters and setters. While we are here, let's do one more thing. Let's go ahead and provide a constructor right now, which doesn't take any arguments and simply a no argument constructor. So that's all I did, not a whole lot. Hey, do I need to do any more annotations here? Well, let's hold off on that. Let things fail, and we'll come back and do more when we need to. So I'm going to leave this as a Pojo with the really no traces of anything related to Micronaut at that point. As the name is, it's just absolutely a Pojo. So that's my stock class that we created. That's all we did. Well, now that we have the stock class, what's the next thing we're going to do? Well, the next thing here is to create a service I would really like to use. And what does the service really provide? A service is going to just eventually, maybe it'll go get the data from a database. But for now, it's just going to be a holder of an object. And in that case, my service is going to be simply a Pojo to begin with. So let's get going with that. So what I want to do here is to say, here's my new class I'm creating, and that's going to be a stock service. That's what I will call it, as stock service. What do I want to do with the stock service? Well, first of all, let's do a private list of stock. And the stock is going to be just a collection of stocks. So we'll simply say stocks right now. That's all I do for now. Well, while we are here, it's probably a good idea to create a constructor which will initialize this data. So we'll say, give me a constructor. So within the constructor, let's do stocks.listOf, and sorry, stocks equal to listOf. Let's go ahead and say equal to listOf. And what am I going to do with the stocks that we are creating? Well, I want to populate a few different stocks in here. So we'll say stocks is equal to, and let's create a few sample values to work with. So what are the values I want to provide right in here? Well, first of all, you can see that's not too happy with me. Let me go in here and say, hey, I want to use the facilities available as per the language version. And of course, I'm going to say new stock. Let's start with the little stock data here. Let's say ORCL, and about $80, let's say, as the price that we would like to see it as. And of course, then I'm going to say a few other stock prices. I'm going to create maybe 3 more of those for us to use. And what are the things I want to provide here? Let's provide MSFT, maybe at a $270 of a price. Let's provide 2 more here. Let's provide a Goog, and that's going to be at a price of $2,600, let's say, give or take. And then finally, we'll put Amazon here. And let's say the price is an insane $3,500. So let's go ahead and put that in there as well. So those are some sample data we created. So now that we have that in place, the last thing I'm going to provide here is a getter, and we'll provide a getter for the stocks as well. So nothing really exciting. But while we are here, let's explore some options we can use. The first thing I'm going to say here is a singleton option. So what does a singleton declaration provide for us? The singleton basically says that when your controllers are creating or getting access to a service, we are not going to create objects over and over and over. This makes really good sense in a scenario where either the service is stateless or that is a shared state you really want to share across multiple controllers, it would really make sense. You definitely don't want to do this in case where there is modifiable, mutable data, but a singleton is a really good option to consider. But Micronaut provides a bunch of different options right from the get-go that we can rely upon. So you can say a singleton, which is a very common option to choose for a service. You can also say a context. Don't use this too often. Be very reluctant. If you feel like you have to use a context, maybe call a friend and ask for advice, but a context is useful. One of the reasons I say that is the nice thing about a singleton is a lazy loading. A context is going to be created when the context is initialized, and maybe there are times when you really want it, but not too often. A prototype is a rather rare also, but it is where you're saying on every instantiation request, I want a new instance being given to me rather than a shared instance. Infrastructure is where maybe this object has to be really created and you want to make sure it's that exact object you are using because you rely so much on infrastructure related details that's been optimized. You could say infrastructure. And again, if you want a new object for every single request, you could ask for a request scope, but I kind of put this in the order of maybe what's more desirable to other options you may consider along the way based on what you want to do. So all you have to do is hoping that you have proper testing is to really make sure that you can change these configurations, simply come down here and modify it to whatever you want to be and run your test and make sure things are working the way they're supposed to. So you got a few different options to really consider along the way. So that's basically about a service we just wrote, nothing really exciting other than simply saying this service is giving me the stock objects when I request for them. So with that done, we're almost ready to work with our controller, which is going to give us the data we are expecting by serving the request. Now, how do we write my controller? So to write my controller, it's extremely easy again. So I'm going to go ahead and create a new Java class called stock controller. And within the controller, what am I going to do? Well, first of all, I'm going to mark this controller like so. It's a controller. So I'm going to say, here comes the controller, and it's going to serve just that access to that URL right when you come in. If you want to give more, you definitely can put more things over here, but I'm going to leave that as it is right now. So once we declare a controller, all I'm going to do is to say right now, a private, let's say, stock service, and I'm going to simply say, here comes the stock service. Now, you can simply do a constructor-based injection. That is one of the nice things you can do is low ceremony, just a very simple way of writing the code. So I'm going to write a constructor using the service like so, and we are done. And Micronaut will take care of compile time dependency injection. So when a controller need to be created, Micronaut will write the code for automatically creating the service and creating a controller using that constructor automatically. So there's no runtime expense in terms of reflection and other things to explore what you are using. This is very well known at compile time. Why bother wasting the time at runtime? That's the philosophy. So then I say get. And in this case, I'm going to go ahead and say, make a mistake, right? So I'm going to say here, ticker, and I'm, making a mistake in typing that name. My wife says I'm really, really fast at typing backspaces, and she has noticed me over the years type and then hit the backspace to correct it. So here I'm fat fingering, as you can see, that particular variable. I say ticker as an error, but we'll see what Micronaut is going to tell me a little bit later. Then I say public stock, and I'm going to say get stock, and this is going to take a string and a ticker as the name I fully spelled out correctly, as you can expect. Then what am I going to do here? Simply say return the stock service dot get stocks. Then I'm going to get a stream from it like so. And then I'm going to say filter and get the stock from here. And I'll say stock.getTicker, and I'll say equals the given ticker symbol. That's what I'm looking for. And once I find it, I can say find first. And if it's there, that's great. I'll return it. If not, what am I going to do? Oh, maybe right now I'll simply decide to return a null in this case. You can think about maybe an optional, maybe a better choice, or maybe a default value you could consider as well, but I'll leave it as a null for now and say return that. So we have a controller in place, but I'm really eager to give it a try. But Micronaut is going to tell me not so fast, because I don't want you to go run the application, execute it, and feel crushed. I'm a big fan of fail fast technologies. Fail fast removes the embarrassment from us, saves a lot of time for us as well. So I'm eager, obviously. I want to go ahead and run this code, but without any compilation, I say run. Obviously, it has got to compile the code as well, and then execute the code at this point, isn't it? Well, actually, this is one of the places where the demo gods are not working with me. I expect this to tell me right now that this controller is supposed to tell me, hey, this ticker is not supposed to be a ticker here. And
the variable bracket is the variable
sorry,
bracket is the curly bracket is missing at the end, so it's still a valid URI. Not an actual
so two negatives makes a positive, huh? so there you go. So as you can see, I'm not just bad at typing, I'm terrible at typing, as you can see right there. And this is one of the reasons I love pair programming. So I've got the best person in the world to pair with right now. He's keeping an eye on it. Hey, you missed us, curly brace right there. Awesome. So let's go back over here and run that code and execute the code. It says, do you want to stop and rerun? Yeah, ambitiously, yes. And there you have it, right? So that's what I wanted to really see, is that syntax error. So the minute I put a curly brace right there, and just not fat fingering, right? So one of the things I always think about is when stuff go into a double quoted string, refactoring is probably not going to help you a whole lot. If I rename that variable, does it automatically rename that variable? Well, the compiler can tell me you're wrong and give me that error right away. So you can see right there, it says public stock gets stuck, and then string ticker, and it tells me that, the route declares the URI variable ticker, but no corresponding method argument is present. You got to give a credit for that. Finally, an error you can actually read and understand. I'm a huge fan. You don't have to call 7 people to look at it and say, tell me what I did wrong here, right? It spells out really clearly right there. That's one of the nice things. So I go fix the error, as you can see right there. And now I'm going to go back to the application, and I'm going to go ahead and fire it up and say execute it. And let's kind of bring it up and start running it. So the application is running, but I really want to take a look at it right away. I'm a person of impatience. I'm a fan of instant gratification. I want to see this running right away. So I go to the command prompt right there, and I'm going to say, in this case, curly, and I'm going to say HTTP localhost and :8080 and slash ORCL. And I'm going to ask it to execute the code for me right there and make a query on the command line, hitting that URL. And you can see it came back with Oracle with $80 price we gave. But I make a mistake. I say LC, and you can see it says page not found. Obviously, it didn't get back the data that I was expecting, as you can see from the call. We can put more messaging and error around it as we may choose to, but that's an example of how we were able to build it. Now, while on the topic, I can also go back to this code right here, and rather than using a constructor-based injection, if I really chose to, I commented out the constructor, as you can see right there. Now I go back and fire up the application this time around, and obviously we didn't provide the necessary details for it, what's going to happen. So if I go back and run with Oracle, you can see that it gave an internal server error. And the reason for that, of course, is you can see that it did not find the dependency injection because we just wrote a field, but the reference is a null. So what could I do? Well, I could do an inject like so. And if you really have a good reason not to write a constructor, you could do a field-based injection if you choose to. So in that case, if I go back and run the code, and if I go back and fire it up and make a request one more time, you can see that's working again. Alternatively, you can also say, hey, I don't want to provide a field-based injection, but I want to write a setter method. Sure, you can write a setter as well. And in that case, you will mark the setter with the inject also, and you can provide it. So you got a few different options, but I tend to really prefer the constructor-based injection because it's pretty low ceremony and we can get going. Another thing I want to really emphasize here, one of the things I care about a lot personally when I create applications is the ability to easily test my application. So what I typically do is I use things like Mockito, and I would mock away my service. And using dependency injection, I will inject the stock service mock object into my controller in my test, and I would be able to test all my methods of my controller very easily. And Micronaut makes testing that really effortless. And that's one of the reasons I really like this idea of dependency injection using a constructor, because that makes it really clear in my mind that I'm really injecting that as a dependency, and let the dependency tools, stubbing and mocking library tools take care of things for me becomes very effective. Now, with that said, of course, one other thing I want to really focus on, it's good that we are able to write this code, but I kept mentioning the word easy to test, but it would be a shame if I really don't show how really easy it is to write these tests. So let's go over here to the test right there. And this also gives a nice segue into the next topic, which is creating a client, because you can say a test is a great example of a client before we get to a real client we want to create. So what I'm going to do in here is to go back to this code and say, I want to create a new test, and the test is going to be stock controller test. And of course, you may say, why have you not created a test for the stock service? Well, sure, typically I do. And especially I write a test around the configurations I place, whether it's a singleton or not. If that is a business specific reason I chose that, I often have a test to verify that the configuration is done properly. So tomorrow, if somebody accidentally modifies one of those configurations, I want to get a really quick feedback loop. So typically, call me, being so, adamant about testing, I would create a bean context, instantiate my services in it, and verify that my configurations are exactly what I want it to be. Again, this really goes back to my business requirements, and I want to validate them in my code. So I create a stock controller test, as you can see right there, and I'm going to ask it to be marked as a Micronaut test like so. And Micronaut says, sit back and relax. I'll do a lot of work for you in terms of injecting the necessary dependencies for us. So what am I going to do? Well, I want to talk to a service. And again, I want to come back to this point of me being lazy. I want things to just work. I don't want to sit there and fight through the libraries and APIs. And this is where, again, Micronaut makes life really easy. I'll simply create an interface right there. I'll call it as a stock client, if you will. So the stock client is an interface, but I mark gently that interface using an annotation called a client annotation. And I simply say, go to that URL, which is just the slash. Then what I can do is I can go to the controller and I simply grab that function right there, so that from the get ticker all the way without including the curly braces, I'm going to just grab that part right there. And I'm going to come in here to the interface and just copy that over into that interface. So here comes the charm. Micronaut, when you compile the code, detects that you have an interface that is decorated with a client. So automatically it creates a proxy for you at compile time so that you can rely upon it. I will show that to you in just a few minutes when we create the client and we can actually appreciate it and see it as well. So what am I going to do? in this case, I'm going to say inject. And what am I injecting? A private, let's say in this case, a stock client. I want to create a stock client. And I bring in the stock client, and we'll simply call it as a stock client. And Micronaut will inject the implementation of that interface for you automatically without you having to put any extra effort. So then I say, I want to create a test like so. And what do I want to do with this test? I'm a huge fan of JUnit 5. And so here is my test. I'm going to say get price for Oracle. And again, I mentioned this a few minutes ago. In a typical scenario, I will stub away or mark away my service, which will return a fake or a canned response for a stock price, and I will verify my controller is doing the right job. But in this simple example, we'll simply say a price is equal to, and go to the stock client and ask for the get stock for Oracle ORCL, and we will simply say assert equals. In this case, we'll say assert equals, and the price is going to be an 80 value. And that's going to come from the price itself, and we can ask it to verify that. So that is basically the little test that we wrote right there. And I think I want to be really emphatic by saying multiple S over there. Let me fix that. And so that's basically the assert that we brought in right there. Well, it's time for us to see if that actually works. And of course, in this case, I want to say dot get price and get the price from it. And let's fire it up and execute it and see if the test is going to pass. And right there, it kicks in. This is actually serves as an integration test at the end of the day. So you're dealing with the real stuff rather than dealing with some hypothetical things. So you can see the test is passing. But I'm a big fan of making sure the test actually fails before it passes. That gives me confidence. I'm not really looking at some false positives. And you can see that the test actually failed right there and said, hey, look, you are expecting a 90, but I got an 80. So go back and put the 80 as a result and execute it. And you can see that executing right there. So I'm going to talk a little bit about creating a client, and then maybe we can spend a few minutes on any questions that may be there. So if you think about questions, now is a good time to ask questions. In another 2 or 3 minutes, I'll be ready to listen to your questions or comments as well. So that's our little service that we wrote. Let me go ahead and fire up the service. Let that keep running while we write a client. You could write a client code right in here if you wanted to, but I'm going to go ahead and create a separate client code, if you don't mind, just to get a feel for how that looks like. So here is the stock info we created a few minutes ago. So MN, I'm going to say help again, as we saw earlier. And you can see there is a create CLI app, and I'm going to just do exactly that. So MN create CLI app, we'll call it as com agile developer stock client dot stock client, and I'll create it as a stock client like so. So now that we created a stock client, let's go to the stock client directory and let's open up IDEA and build.gradle, and let's fire it up right there. So it says, do you want to go ahead and bring it up in the same directory or a different executable? And I'm going to say bring it up in a new window. Let me ask it to say, give me a new window, please. And right there is a new window with the client. What did it create for us in the client? Well, when you take a look at the client itself, that's a nice little CLI application. So if you want to really process your command line arguments, well, a lot of that is done for you already. Again, that's what I really like about Micronaut is it's a tool that keeps thinking about what you want to do and minimizes your effort. So right there, it said you want to bring in command line options and deal with them. Not a problem. We got you covered using the Pico CLI runner, and they'll do all the parsing of the data and such and bring that in. But of course, I'm not going to do any of those right now. So I'm going to keep it rather really simple. So let's go back here and simply make sure it prints out hi on the command line when I run the code, and you can see the hi being displayed. But of course, we didn't come here to greet hi, even though that's part of what we do. We need to go a lot further, isn't it? So let's go ahead and create a little client-side code for ourselves to use. So what am I going to do here for the client code that I want to create? Well, for the client code I want to create, I want to bring in a couple of things. Now, let's pause for a second and think about it. If you are in the same project, you can share the source code. But keep in mind, one of the things we do in the world of microservices is we try not to really share a lot of code. That is not to say we will not share the code at all, but we don't share the code as extensively as we do in traditional applications. So in this case, if we have to keep the domain model separated, we often do. So for that reason, I'm going to go ahead and create a stock class like so. So I created a stock class in the new project. Notice this is a stock client package, but as you can imagine, in the older project, I have a stock info package, which contains the stock class. But I'm going to go ahead and take the stock class. And if you really wanted to, you can put it into a separate jar file and share the jar between the two projects. You can definitely do that. You don't have to duplicate the code. But if you want to keep them separate, you can also. It's entirely your decision to make. Micronaut doesn't impose any requirement on you. So you make a decision that is appropriate to your project, your architectural constraints and decisions. That's your call. So I brought in the stock class, but while we are here, let's write a toString method as well. And the toString method, I'm going to simply say, well, what do I want to say? Return the word. Let's say in this case, return a string.format. Let's go ahead and say string.format. And I want to say a stock, and let's put a little colon, a %s, maybe a couple of dashes and a %d. And then finally, let's go ahead and print out the ticker and the price as well. So that should be good enough for our purpose. So that's our toString method for our stock in the client side. What do we want to do with the client itself? Well, with the client, I'm going to do one more thing. I'm going to go back here and create an interface. And the interface I want to create is called stock client. And the stock client is an interface as you would expect. Now, what do I want to do with this interface? Well, if I go back to my stock client, I created in the test like so, I can use this interface right there. I'm going to just copy that interface that we created from there all the way into this project right here. So I brought in the stock client, except for one small detail. We don't have, we cannot, well, first of all, where's the client coming from? Well, the client is from Micronaut HTTP client. So what I'm going to do here is to go to the build Gradle, and I'm going to just go ahead and import that right here. So I'm going to say, bring in the dependency on Micronaut, let's say HTTP client, right? So that's the dependency that I want to bring in here, which is going to be the Micronaut HTTP client. So I'm going to say HTTP dash client is what I want to bring in. Well, that is because, remember, I created this as a CLI application. Micronaut tool doesn't know what I'm going to be doing, but you can see it doesn't take a whole lot of effort to bring in that dependency as and when we really need to bring in. So we just did that. So I'm just asking IntelliJ to refresh the build Gradle file, and I'm off here and asking the import, and that's our client, except one little detail. Where is the URL that I'm going to communicate with, right? That's important for us to know. Now, clearly, I don't want to put HTTP and :/ you could, but that's not going to leave a lot of friends for us, right? I mean, who would want to hang out with people who hard code stuff into source code? Gosh, it gives me jitters even to think about it. And so what am I going to do? I'm going to simply say, let's configure this for ourselves. So I say ID is equal to, we'll call it a stock client. We'll see where that comes from in just a few minutes. So we provided a stock client right there as a ID, and we have a reference to what to get it from. Just an interface, that's all we have. One more detail. We'll go into the resources, and in the resource, we have an application.yml, good place to tell where the service is located. So let's pull up this application.yml YML file. And what do I want to say within this particular file? I want to tell the file, hey, I want you to know that I have a HTTP client that I'm going to use, and that client I want to use is located in some place. Now, in the next part 2, we will talk a little bit about how we can use load balancing and such, so we don't have to hard code in the configuration either, and we can provide different ways to bring in a discovery, but we're not there yet. So we'll just code it here. We'll use discovery in the part 2. So in this case, I'm going to say HTTP. And what do I want to specify here? Well, that's going to be the services that I'm interested in. And the stock client is the service. What is this name, stock client? That's the name I provided in the interface, stock client right there. I'm just using that name right there. And then I say, here comes the URLs for it. If you really want to do load balancing, you can trivially do that here by giving all the URLs. But ideally, you would want to use other mechanisms to do it. But in this case, I'm going to simply say HTTP localhost. So localhost 8080 is the URL where I'm going to pull that from. So that's basically the configuration we wrote. Let's go ahead and close that up right now. And final part to get this code working, what am I going to bring in? So I'm going to say stock client that we have already with us. Where do we have the stock? Oh, I forgot that, didn't I? So let's bring in the stock client. So I'm going to say private stock client is going to be the client that we are interested in, a stock client. But we can simply tell, do me a favor, Micronaut, inject that for me so I don't have to do any work. Remember, stock client is an interface. You need an implementation of that at runtime. So what am I going to say here? I'm going to simply say output, and here's the stock client dot get stock for ORCL, and maybe we'll get the stock for Microsoft as well. So we'll say MSFT, and we can take a look at the stock price for both of those. Well, almost time to execute it. So let's fire it up and see what it wants to tell us. So here's the program that shoots up and fires up. And you can see from the output, here is Oracle and MSFT. But what happened? I'll honestly say, I don't like the word magic and programming on the same line. Micronaut feels like magic, but it definitely is not magic. Magic is hard to debug, hard to understand, hard to work with, but I like technology that is simple to use. So if you look over here in the build directory under classes, you will notice Micronaut has been working in the background for us. And so here you can see the stock client, and there is a stock client intercepted, and I can take a look at the bytecode, and you can see the stock class generated and classes like this being generated in the background. And notice this implements the stock client interface that we talked about a few minutes ago, but that has been generated for us at compile time. And as a result, the dependency injection is injecting an implementation of stock client into our stock, the injected point, wherever that was, which is pretty much right there. That's the instance it's going to receive. And if you're really, really curious about it, right, as I like to poke around sometimes, I'm going to just display the stock client itself to see what in the world it is. And you can take a look at the information it provides, and you can see right there is a stock client intercepted. That's the class name that you see right there that was synthesized at compile time for us. So there's no runtime expense related to that. So that's where I'm going to stop this little segment. We're going to talk about reactive. We're going to talk about JVM and such. We got about 30 plus minutes with us, but I want to pause and see if there are two things. One, any questions from anyone in the audience? Also, any comments from either Graeme or Oleg, and see if you want to interject anything at this point as well. So I'll just take a pause and yield to listen to other people's voices.
So one nice little optimization you could apply is the test. If you the test that you was using the client. I know that you like low ceremony. So when I write tests, I actually like to just declare the client as a method parameter to the test. And what Micronaut test will do is it will inject the client into parameter of the method, which saves a few little lines of code. So that's one little tip.
That's awesome. Wonderful. Even less verbosity for the win. I'll start using that from the next time. So thanks for the tip.
Yeah.
Other thoughts, other questions, if there are any questions from the audience also.
Yeah, there are a few. And some of them are positioning Micronaut against other existing frameworks. But there are a few particularly asking about Spring Cloud. I'm not sure how much you are like in touch with that technology, but how do you maybe compare them and put on the like mental plane where they sit? And also Masood is asking, is there any equivalent of Spring Cloud Gateway in the Micronaut world, and whether Micronaut supports R2DBC, so the reactive client, which I assume you will get a bit later as well, but yeah, just take it.
Yeah, so the question about the R2DB, we'll talk about databases and reactive as well in part number 2. But for the other question, I want to see if Graeme has any input or comment about the other part of the question.
I assume the other part of the question is about Spring Cloud. So there's no directly equivalent to Spring Cloud Gateway, but it is very simple to write gateway implementations using Micronaut's declarative client. So what I tend to do is use the declarative client, and it basically points to your target service. So and it just proxies methods, because what a gateway is essentially a proxy, one service to another. So you essentially can expose a client as a controller. So it's an interesting trick that you can try is you can actually have a interface that is annotated with both client and controller, and it will map to the same URI and basically route requests to the outgoing service. Yeah, introducing even less ceremony essentially. So it's like a declarative way to define a gateway, right? A client that has a particular ID that maps to a particular route. And it's pretty simple to do. And if you just want to like send bytes across, you can make the methods of the clients return byte buffers, and it will just buffer the bytes one way to another. So it's pretty simple to define that. And then the other thing that we have in Micronaut as well is there's a proxy client as well, so which is a bit more low level. So you can again inject a proxy client by ID, by service ID, and that can be looked up using service discovery, either through console or Kubernetes or whatever service discovery mechanism you're using. And the proxy client has a richer API, more low-level API for proxying requests from incoming requests to another service, which is exactly what a gateway is, right? And for most of the other things, there are in Spring Cloud, there are essentially equivalents. Micronaut declarative client is essentially this to Spring Cloud thing, I believe. And Micronaut has built-in service discovery for console, Eureka, Spring Cloud server, Kubernetes, AWS, Route 53, and many different backend implementations that you may want to hook up service discovery to via Spring Cloud.
Thank you. I want to jump in and talk a little bit about reactive programming and show a little example of how we could turn this into being reactive. And I'll swim back with another question for Graeme at that point about maybe changes coming in the area of reactive programming with respect to RxJava versus maybe potentially reactor. But let's take a look at what that really means in this context. So reactive programming, I want to spend just a elevator pitch on what it really means to be reactive. And I'm going to say, I look for maybe three things when it comes to reactive programming. The first thing I look for is a stream of data, a data flow. So maybe I have a large volume of data I'm going to expect, and I want that data keep flowing towards me. So a data flow. The second thing I look for is back pressure. So maybe as a client, I'm going to process at a different pace than a server sends me data. How can I handle back pressure when a stream of data flows towards me? The third thing, probably the most exciting part, is non-blocking. So I want to make a call, but I don't want to block and wait on the response. I want the response to be non-blocking. So if you have the need to do any of those three things, you may consider going for a reactive API. So in this case, of course, you have a publisher and a subscriber that you're going to use, but how do we really create a reactive API? Well, as it turns out, it's really easy to do. So let's go to the controller, and in the controller, you can see that we have a function sitting right here, which is going to provide for us the, oh, where's the controller? Let's bring in the controller right here. So in the controller, you can see we have this function, which is the get stock function, right? That's returning just a stock. You know, clearly what I could have done is I could have done a list of stock. There's nothing wrong with that. I could say get stocks and write the code like so. And while that's definitely an option, no doubt about it, what I'm going to do is to change it to a flowable in this case. Now, typically, you might get a data from a database, if you will, where the data may be coming as a stream of data. Potentially, you could get a stream, or it could be from another service that you're talking to, what have you. So in this case, what I'll do is I'll simply turn that into a get as a function right there, and then I'll say return. While I can simply say a flowable dot from iterable, if you will, and I could say, you know, from iterable, I can simply say, you know, stock service dot get stocks. You know, I can definitely do that. But I want to do something a little different just to illustrate the point. This is perfectly valid code. And typically that's what you would want to do if the data is coming from a database. You just want to turn around and call it. But what I'm going to show you is not what you want to do, but just to illustrate the behavior in this code. So I'm going to say return, and I'm going to say here is flowable dot interval. So I say one time unit dot seconds, and I'm going to start really streaming the data once a second. It's a self-induced you know, delay just to show how this actually works. Then I'm going to do a map on the index. And in that case, I'll simply say, well, this is going to be, pardon me, this is going to be a list of stock. We'll call it as stocks is equal to, and let's go ahead and say stock service dot get stocks. So we have stocks on our hand. And let's go ahead and say this is going to become the stocks dot, let's say this is going to be the get at the index dot int value. And then one more piece of information. We'll simply say dot take, and we'll say stocks dot size, only give me that many amount of data and be done with it. So let's go ahead and save that away. Now notice all we did was we returned the flowable with that being coming in an interval, as you can see. So now let's go over to the application and let's just fire it up right there and execute the application code. And you can see that running right now. And I go back to the command prompt and I fire up the old URL that we requested. That's still working. However, I'm going to go back and to the curly, I'm going to provide no buffer, and I ask it not to buffer the call. And then, of course, in this case, I'm going to just go to the 800 and make the request right at that URL. So at this point, we just made the request to, let's try this again. So I'm going to say no buffer. So let's try that one more time. There we go. And I make the request to that URL. And notice now we got the data streaming through at a 1 second interval as this is flowing on. So at the first second, third second, and fourth second, and we got the data coming through. This is really saying, hey, you're going to start streaming data on one side. I want to start receiving on the other side. Now think of the possibility. Your Micronaut could be your server that you are creating, your front end could be a React or an Angular or a Vue or a plain vanilla JavaScript, and you can stream the data. And on the client side, you could be processing that using any technology you want to use. It's entirely up to you. So this gives a nice opportunity for us to stream the data through and be able to process it on the other side with almost no effort at all, as you can see from that little exercise. So that's basically what we saw here. So you can start providing the reactive stream API, and as the data may come from a MongoDB, for example. Earlier, I think it was Masood who was asking, what about the, talking to relational databases? Well, sure, you could try that. But in all fairness, though, the R2DB is not really that mature in comparison to a lot of other things. But one of the things I like about NoSQL databases, for example, like Mongo client, is that it can provide you a stream of data already. And so if you were to hook up your services to something like that, you can start streaming data readily. And so then you can have an end-to-end reactive application. So your database can start emitting data, your Micronaut application can route that to the client, and your client, either it's Micronaut or another technology in Java or a JavaScript technology or anything else, maybe a .NET technology, doesn't matter, which can start receiving the data. And now you can have an end-to-end reactive application where right from the database on one end to maybe a browser on the other end, connected throughout by reactive stream. Now, I often say a good example where we probably would use some of these ideas is like in pagination. So you want to send 100 or 1,000 pieces of data, and when the user has seen that and scrolls through, you want to get the next page of data. Implementing pagination in the code is the lowest point of programming, in my opinion. It is so boring. Well, if you can do end-to-end reactive, you can bake pagination into it. When the user scrolls, you simply say, get me the next set of data. Well, the database knows what it has sent to you and can start sending more rows of data, so you can really enjoy the benefit of being reactive throughout. That's an extremely powerful idea. So we saw how we could be reactive with it with almost no effort at all. And of course, you can build on top of this with more reactive libraries and such. But I'm going to yield for a minute and listen to Graeme. Are there changes we are looking at in terms of the library implementation moving forward into Micronaut in terms of reactive programming? What can we learn about what's coming up in the future?
Yeah, so Micronaut 3 is just around the corner, and it's not far from being released now. We're hard at work on testing and getting everything compatible with it. And yes, in Micronaut 3, one of the changes we're looking at is to move from the default library in Micronaut 2, which is RxJava 2, to using Reactor for Project Reactor as the default reactive library. A lot of different reasons for that. One of them is, in fact, R2DBT, which was already mentioned. So most of the drivers for that are written in Reactor, which means that if you're trying to do context propagation and distributed tracing, it's easier to do that if there's a single reactive library used for the entire flow. Otherwise, you kind of have to trace interactions between different reactive libraries, which is very challenging from a tracing perspective. And apart from that, I think, in general, Spring users are more familiar with the Reactor, and obviously, we want to make sure that those folks are comfortable using Micronaut. And I think it will be a good transition, given that we had to make a change anyway with the presence of RxJava 3, which has just come out, just about a year ago, I think. So we had to move anyway. And so we're looking at moving to Reactor for that, which I don't think it will be too disruptive of a change, because RxJava 2 will continue to be just supported. So if users are upgrading from Micronaut 2, they'll continue to be able to use RxJava 2 just like they were before. It's more talking about the default that people use, and when they initially create a Micronaut application, right? So yeah, that's the big change coming up. I think users will enjoy it.
Awesome, thank you. So that brings us to the last part of this segment, this presentation part one, which is we want to talk about building for a few different environments. Obviously, we are using Java here. We are running it on the JVM, and that's what we're noticing here. So what does it take to really build for the JVM? I want to note down 3 different things here for us to notice. We'll talk about the startup time. And one of the things about time is we got to be a bit careful, right? Depends on what other things are running. One of the things I've learned in my life is you can use Zoom or you can do something else, not both. So look at the time, very subjectively. I haven't run this with Zoom, honestly, recently. I don't know what the time is going to be, but I know what the time is when I don't run Zoom. So if you see the time is really large, keep that in mind that I'm running Zoom right now. In fact, I have to hold my computer down because the fans are running so fast, it wants to really lift my computer up. So that's basically the cost of running Zoom in general. But I'm delighted that I'm able to connect still, but other things kind of slow down. But we'll take a look at it. Again, relatively speaking, we'll look at the startup time. And then we'll say first request, and then we will say, more requests, how much time it's going to take for subsequent requests as well. And we will take a look at some of the times for those. And then we will compare that again with what happens when we use, GraalVM. So let's talk about the startup time. But before we do that, let's go back to the command prompt. And in the command prompt, let's see where we are. So I'm going to go ahead and go to the stock info right there. And in the stock info, I'm going to be able to build this right now. So I'll say Gradle W. And again, if you're using Maven, you could do similar things. And I'm going to say assemble and ask it to really build the jar for me. So I can just run it on the command prompt and take a look at it very quickly. So right now you can see under the build directory, we have a libs directory, and then we have these jars sitting right there nicely. So let's do a Java -jar, and let's bring in a build a libs. Let's say this is going to be the stock info all, and I'm going to just bring that in and execute it right there. So when I fire it up, you can see that it's going to start that up. And of course, this application is running and it's not too happy with me right now. So I'm going to close that out. So let's go back and run that code. And you can see right there, it's about 717 milliseconds. I'm going to run it a couple of times just to get a feel for it. So 699. So we could say in the ballpark of about 700 milliseconds. That's a fair enough thing to say, right? So give or take about 700. So I'm going to say this is about 700 milliseconds for the starting time. Okay, it's not too bad, you would say, and I would completely agree. That's pretty good, actually, compared to a lot of other things, but we could also do a lot better than that also. But what about a time for the first request? You can see that's running right there, but let's go over to the command prompt right now again. And in the command prompt, let's do a time, and let's just measure the time it takes for curly to run through HTTP localhost, let's say 8080/ORCL. And of course, you know that the reactive stream library, I delayed it intentionally. So that's not going to be a good measure in this case, but we can ask for the Oracle and ask for how much time it takes. So you can see about, 0.0237 seconds. I will just look at the real time right now. Again, very approximately, let's note that down right there. So again, I want to kind of see that one more time. So let's kill it again and fire it up one more time just to see what it takes for the very first request to come through. So fire it up, and so approximately that's kind of what you're noticing. So that's good enough for our purpose. But let's go ahead and fire up one more time, and one more time. You can see somewhat of a different story this time. So when you look at this now, you can see the difference in the time, and that's about an order of magnitude less, as you can see. That's because things are warmed up and you got the JVM, done its work. So clearly that's the time you're looking at. All right. So what about the GraalVM? Well, I'm going to say a couple of words, but I'm hoping that Oleg will be able to talk a little bit more about it to kind of get us motivated. So GraalVM, of course, is a polyglot environment, which is really geared towards super performance, and for native really deployment. So you're able to run close to the metal, if you will. But one of the key things about GraalVM is that it doesn't do reflection at runtime. It depends on stuff to be known at compile time. The philosophies are very similar to the philosophies in Micronaut, so they align really well with each other. So obviously, Micronaut determines a lot of stuff at compile time. GraalVM loves that it knows things at compile time, so it's able to generate the binaries natively so they can run really fast. So why would you consider something like a GraalVM to run your application? And the answer is, speed, polyglot environment, performance, and really geared towards applications that fit into the same nature of things we want to build with Micronaut. So while Micronaut can be the framework for building stuff, GraalVM can be the environment to run the code, if you will. So that's one of the reasons why we could get excited about. But I'm going to yield for just a few minutes to see if there are other comments that we want to hear about GraalVM itself.
Right, interesting introduction. Yeah, I don't think we have any comments yet on YouTube, and while we wait for a few seconds more of the delay between the stream, yeah, it's I just want to say that this is correct. GraalVM at its heart is about performance in all various means and ways, right? And what is very necessary not to forget is that at the heart of the project is also a JDK implementation, right? So you can use it for running your applications. Actually, I was wondering what Java version and distribution you're using for those tests on your machine for the startup and first requests.
Yeah.
Could it be GraalVM as well?
Yes, I am actually using with the GraalVM. Yes.
Very, very good. That warms my heart. See those 700 millisecond startup times? That is the GraalVM distribution, right? And of course, then there is it's a compatible thing that doesn't have any problems with any Java code that you throw at it. And what you said when you said about the reflection bit, this is specifically about native image, which is a sort of a mode of execution where your application gets precompiled, and for that compilation ahead of time, it uses static analysis. So by nature being static, it needs to have additional explicit configuration for few dynamic features like reflection. So it doesn't have a problem with running code that uses reflection. It just needs some hints or some explicit configuration during the build time, which is where this synergy between GraalVM and Micronaut come in, is that Micronaut generates those many things that libraries typically do using reflection or using dynamic proxies and such. Micronaut generates classes ahead of time with the annotation processor. So, and since those are normal classes, which sort of call each other through dot notation, right? Then the static analysis can very easily parse and understand those. That's why you need less configuration for those dynamic features when you use Micronaut. But this is just a filler, right? That don't filler to wait for some questions to appear in the chat. So don't.
So I do, yeah. So that's good to hear, and I do want to show one small problem I postponed just to illustrate and come back to what you mentioned just now, Oleg, is that it needs to know that information a little bit ahead of time. So in fact, that's what we will do here. Is if I go back to this code and do a GraalW, and I'm going to say native image and build a native image, it's going to pull in as much information as possible at compile time. As you can see, it is drawing on those details right now. So here I'm using the word application, that is the default, which is fine if that's what you want to really use. There's nothing wrong with it. But if you don't like the word application, you can also configure that, if you will, to something completely different. And I'll show that really quickly, how easy it is to do that. And all I'm going to do is simply add this to the build.gradle. So I go back to the build.gradle like so in here, and you can see right at the bottom of this, I'm going to just throw in that little thing called stock info. So that is telling me, no, don't call it application, call it stock info. So if I go back over to the command prompt right now, and as you can see that it's building it using the analysis, which is fine. The next time we'll use a stock info as a name, but you can see that it's parsing through and building the binaries for all the dependencies and relative things it is looking for. So you can already see that it's doing a lot more work time, and as a result, it's going to save it all that time at runtime. But one of the caveats here, though, is we got to make sure that everything it needs is there. Think of this as, getting on a ship. You better have everything you need. So you need to spend a little bit of time. It's going to be wicked fast once it leaves, more like a spaceship than a sea ship. But you better have everything, before you go. So in this case, you can see that it's building the application right there. And next time I build it, the name will be different because I configured it, as you can see, with a different name than the default application. But if I go back here and do a build native image and run the application, you can see that of that was 18 milliseconds on my machine, compared to what we saw earlier, which is, let me go ahead and copy this over here. So we are seeing a difference here of 18 milliseconds compared to the 700 milliseconds we saw earlier. But we're going to run into a problem right away as you get into this really quickly. Oops, it looks like I copied too many things. So you're going to look at a problem you're going to run into pretty quickly. Let's see what that is. So if I go back to this code now, and if I fire up the request as we did before, like we executed, notice that didn't go really well. Now, what happened? Why is there an internal server error? Well, if you look at the error right now, it's complaining to us that it's not able to serialize the object. That's basically the error you're getting. No serializer found. And this is one of the things you got to keep in mind along the way. So what I'm going to do is to go back to the server, and in the stock class, I'm going to go ahead and annotate the stock class, giving a hint to it to say, hey, you know what? I really need more information about it, because at runtime, I'm going to be pulling in information about this particular class for serialization. And as a result, I need to have a little bit more details coming in, and you can ask it to provide that detail for you. So this is going to be the annotation that you're going to provide right now, and say what is it called? Introspected. So you're going to provide that little annotation that you're marking right there. So now that I marked that one, let's go back here and kill that one. I'm going to blow away the build it directory and rebuild it this time, just to be sure we got a different name coming through. And I built that application right there. Now notice this time around, it's called stock info, not application, because I made the change in the configuration. So you can call it whatever you want to call it. And once that build completes through, not only will we be able to start up really quickly, but also to be able to execute it as well without getting this internal server error. So I'm going to keep that ready for us to execute. So while that's building it up, you can kind of look at that and see what are the things it brings in. And you can also intermix with GraalVM native libraries and libraries written using languages like C, for example. So if you want to really target to a particular platform and you have a very, very specifically written algorithm which is optimized in some other language, you can build them together as well. And you can go to the peak performance. But like Oleg said, one of the beautiful things about this is you are getting all that benefit, but without compromising on the power that the Java and the JDK brings to you. So you can use Java, you can use JDK, but you can run at the raw speed, if you will, of the underlying architecture or underlying hardware. That's the best of the both worlds. And you are able to see that very clearly in this example on two fronts. One is the startup time you already saw, which was 18 milliseconds compared to 700 milliseconds you saw a few minutes ago. Now, clearly, you're going to take a little bit more time in compiling things and building them, but hey, well, that's a small price to pay. But when you run this application now, and now is the native image, but the name here is called the stock info. And again, you can see 16 milliseconds. Well, okay, almost the same. Maybe the name was a little shorter, right? It's faster. No, just kidding. So essentially, it's about the same time for running that. But what about the initial request, right? Remember what the initial request was. You can see 0.237 seconds. That's what you saw. That's because the JVM has to start doing its processing behind the scene. But when you run this code, you can see that's your first request right now. And just to illustrate that, I'm killed that and restart it, and I go back and fire up the request. It was 0.28, but I request another time, you can see 0.27. So approximately the first request was already, you can see, much faster. What about the next request and the next request after that? Let's just fire up a few more requests. You can see all of them are about the same. So you're not really losing. The first request is no different from subsequent requests. I could easily say that this is about the same in terms of what it provides, because every request is going to be pretty much serving you at the peak performance. And this is especially important on a serverless computing, because you're not saying, oh, this is a first request, you got to pay a little toll, albeit a very small toll. Why bother paying that if you don't want to? So you're able to enjoy that speed of performance as well. And you can see that really GraalVM, not only on a startup time, but also on subsequent request as well, comes through pretty nicely. So that's all I have right now for this part. I'm going to listen to if there are any questions or comments from anyone else. And then really quickly, a few words about part 2. We're going to jump in part 2 and talk about a few other things. Some of the favorites that I have in there are about discovering services. Graeme mentioned earlier about console. I will show an example using console, how we can use that. We'll talk about repeating requests on failure. We'll talk about circuit breakers, another very favorite topic for me. We'll talk about getting data from database and a little bit about deploying to the cloud. So that's what we have in a couple of weeks on part 2. And I hope this was useful, but I want to listen to your questions if you have any for the next few minutes, and also comments from Graeme and Oleg if there are any other comments before we wrap this up.
Probably I'll cover the technical aspects of introspective and why it's called that and what it does. So in the Java API, there is in the normal JDK, there is a class in a package called java.beans called introspector. It's called java.beans.introspector. And you can use it to retrieve information about a Java bean, right? So you can use it to retrieve the properties of a Java bean and find out what they are, right? So the technical function of that introspector is essentially a build time replacement for that API, the java.beans.introspector API, so that we can at build time work out what are the properties of a particular class and know how to read them and write to them if they're immutable at runtime without using reflection. So the technical reason why this works is because it eliminates reflection from the JSON serialization and deserialization. So it's actually a great optimization even for JIT mode, right? Because without this annotation, it's essentially using Java reflection to read and write the properties of your POJO, which has its overhead. And if you look at Jackson, for example, they have tried to optimize this over the years. There's a library called Afterburner, which basically generates bytecode at runtime to improve the performance of serializing and deserializing JSON objects by doing runtime bytecode generation to eliminate reflection. So with that introspective, you're essentially doing build time reflection. So at build time, it computes exactly, it knows exactly how to instantiate, how to read, how to write your objects without using reflection runtime, which reduces the memory consumption, overall memory consumption, because the reflected data is no longer needed. It's not needed for the JIT, and it's not needed for the native image, which will improve your overall memory consumption as well. So that's the technical reason for that introspective. It's not always visible in Micronaut code because it's often used as like what we would call a meta annotation. So, for example, if you had JPA or Micronaut data in this project and you had @entity on that stock class, for example, it would be implicitly introspective, right? So it's sometimes invisible in that it's applied automatically to @entity or certain types. The behavior is the same. Is the work is at build time, and Venkat can expand his build directory there in the classes directory, and you will see under in the generated classes for the stock class there will be a $introspection generated at build time, right? And that's exactly what knows how to read and write to your stock class, and knows how to instantiate it, and it knows how to create it and write to it, so forth, without using it.
Right, and I would just like to add that there was a recent video with Graeme about introspectors and Java records in Micronaut, and you can find that.
Yes.
Link, and we will add that somewhere. So if you want to know more details about how that works and how that particular feature interacts with Java 16 records, then yes, there's a chance to learn from Graeme directly. And then Venkat, that brings me to another question from Kango. What version, like you're using GraalVM, and there are several distributions based on Java 8, 11, and 16. Which version are you using for the native image compilation, I assume?
Yeah, so the one I'm using is not the 16, but the 11 version. I did run into a few compatibility issues on my machine with 16, mainly because of the version of 16 I was using, besides the one I was using with GraalVM. So in this case, I'm using the one with so if I go back here to examine, so SDK list Java, so I got these versions installed, but as you can see, I'm not currently using the 16, I'm using the 11, but I could be using the 16 as well. But yeah, so those are the versions. And for Java itself, I believe I was using the 16, but I got a bunch of different versions running on my machine, which is conflicting with what I'm using.
Right, very good. I agree. This is a good choice. I think in general, specifically for building native image, I think currently Java 11 based GraalVM distributions are the easiest to go, right? So our builds based on JDK 16 are still experimental, and there are great progress, and this next release there is even more progress, but I think 11 is the most straightforward to use, and this is what the majority of people using GraalVM for native image are using successfully. So that was a question from chat, and there was the comment from Marek, not exactly a question, but saying that having a less than 60 milliseconds startup cold start and less the 100 milliseconds subsequent requests makes Java and Kotlin usable for Lambda. So very, very good work, which is a good comment. I would like to personally, maybe not ask, right? But I think just a comment, if people watching us think about the performance of those particular numbers for the startup and request, one of the excellent benefits of using native image specifically is that it performs really, really well in those constrained environments, like with just little resources that you usually use in the cloud. So your laptop probably has a few cores, even if it is running Zoom and video camera and screen sharing, still probably has quite some parallelism available, which helps the hotspot to start fast, and then the compilation happens in the background, right? So because it has those resources, and I know it has those resources because native image build succeeds in like 2 minutes. If it wouldn't have resources, that would be like closer to 5 maybe. But native image, because everything is pre-compiled, right? And it doesn't need to do like any background work like jitting the code, right? It can perform with the same kind of measurements in a much more constrained environments, like maybe with 500 megabytes of RAM and like maybe 1 CPU, right? Which typically would slow down execution on the JVM quite considerably. So just a comment, something to keep in mind if you're watching us and you would like to experiment yourself, try to kind of publish it into the environments that you would run it in the cloud as well. But other than that, like, yeah, I think it's a fairly representative numbers for this small app. Very, very excellent job.
Yeah, and I think also, as you said, or like native lets you take applications that are written in Java places where they just couldn't go before. We see people using Micronaut and native a lot in the IoT space, for example, where you have on-device, devices with constrained memory, etc. Not as many resources available to you. So being efficient being able to be efficient is really awesome, right? And it also allows you to like scale up and down your infrastructure. Like, for example, if you're planning to grow in the future, which most people are planning some kind of growth, you can, for example, run multiple instances natively on fairly limited hardware, multiple instances of the same application on different ports. And they could be independent microservices. So you can run those microservices on the same hardware. And as you grow and your requirements grows, then one day you can move some of those microservices to other machines. But if you, for example, are running multiple processes and multiple Java virtual machines on a single machine, that's more challenging to scale in JIT mode.
Yeah, very good addition. Thank you. There was a comment. If we talk about, there was a comment in the chat about Swagger and about API documentation, and this is maybe something that you will cover in the second part of the webinar as well, Venkat. But if you have any words on support of the API documentation, things like Swagger and usage of those in Micronaut.
Yeah, I think we can talk about that in the part 2.
Yeah, I think that would be great.
I think that'd be a great topic of discussion, and Micronaut has great support for Swagger. And the thing that makes it really interesting is, the way Micronaut processes your source code. That gives it a lot more knowledge than any other tool out there that, it leaves everything to runtime. And that kind of flows through into our Swagger integration, because with Swagger, what we do is we actually parse your Java.comments comments in your source code and place those into your Swagger documentation, right? So that you don't have to add additional annotations or duplicate essentially documentation that already exists in your Java doc, right? So, and that provides a really great simplification, because as a developer, I'm just like writing normal Java doc that goes into my Java doc API, and then also flows through into my Swagger definition. And I'm It's getting processed from my source code into my Swagger definition. And it's really a powerful feature of Micronaut that we can process source code and have that knowledge of things like comments, right, which are completely lost at runtime.
Yeah, that can tie together the fleet of your microservices together very, very nicely. And because documenting is something that I don't know very many developers who like that and like keeping that in up to date with the source code, right? Even less that we love testing. I mean, everyone loves testing, right? But very often people just don't do it. So the same is with documentation, right? I don't see any more questions in the chats. Thank you everyone for joining us today. This session is available directly on YouTube, so you can rewatch that at any opportune moment. And there will be a second part in 2 weeks, right? Venkat, do you want to say any closing words?
But thank you, and I hope to see everyone in about 2 weeks. And thanks to both of you for providing such an insight. I appreciate it. Thank you.
Thanks a lot, Venkat. That was great. Great session. Really enjoyed it.
I loved it. It felt so nice to witness you do a session again, like as in good old pre-COVID times. Yeah, that was absolutely excellent. Thank you very much. And I see people in the chat agree with that and say how much they appreciated the session. So thank you very much. And we will see you all in 2 weeks for another second part of this webinar. Accidentally, also there is a session on Thursday, so make sure that to follow the GraalVM socials and to see to catch up and like be with us in the community. By the way, I remembered, Venkat, I have a question for you about Micronaut. In the beginning of the session, you said that if you want to use like add context or something like this, annotation for the injection, call a friend and ask whether you should actually do that. And that reminded me, where did this friend hang out? What is a good community to ask questions about Micronaut? How can people learn more about Micronaut? Any tips from you on that subject?
Well, I have an easy time. I can just call Graeme and ask, but I think it's important to know what the right channel is. So Graeme, do you have suggestions for that?
Yeah, I mean, we have a lot of great channels. So we have on GitHub, we have GitHub discussions available, enabled on our GitHub repository. So you can go there, open up a discussion, and all the committers, of which there are many on Micronaut nowadays, watch and pay attention to that. And you can have a discussion there. If you're looking for a more kind of chat-oriented experience, we have also a GitHub channel where you can get a community where you can essentially sign in with your GitHub account and come chat and join the various. I think there's well over 2,000 members of that channel, and lots of people talking about Micronaut every day. There's also things like Stack Overflow, which we keep an eye on as well. And of course, a lot of Micronaut engineers are frequent speakers at conferences. So if you want to come to one of the talks and ask questions there, that's also a great venue. And finally, I'm also available on Twitter and LinkedIn and various other social networking medium. So just connect with me, and I'm quite happy to answer any other questions that you might have related to Micronaut and any doubts that anybody might have.
I'll just add one more thing to it. I honestly did spend a lot of time reading through Micronaut documentation, and I do have to say that's been really helpful as well. Documentation that actually tells us useful information. So kudos to the effort on writing. I've spent a lot of time reading that as well.
I should have pointed out the most obvious, right? Which is docs.micronaut.io. You go there, we have, I think like it's around about a 300-page user guide manual, which covers a lot of like Micronaut and the way it works. The interesting thing about our documentation is we use ASCII doc to test actual snippets that are actually in our tests. Every snippet you see is real code that runs on every build of Micronaut. And so the user guide documentation is great. And then there's also guides.micronaut.io. So if you go to guides.micronaut.io, and those are more like focused tutorials on specific topics. So there you will find, guides on things like how do I connect Micronaut to Oracle Cloud Autonomous Database, or how do I write a Micronaut Lambda and deploy it, right? Or how do I connect console, those kind of like focused guides with sample code associated with them, and for each guide. And there are also multilingual, multi-language. So the guides are typically in Java, GraalVM, Kotlin, all the different languages we support. We'll have a big amount of work on our hands when we introduce another language there. But yes, the guides are also great. So guides.micronaut.io, check it out.
Yeah, I second that. The guides for the Micronaut are amazing, and not once I found the exact examples of the applications that I was looking for to build like a small microservice. So if you want to, especially if you want to connect to some third-party technologies, like, I don't know, certain databases or Kafka or I don't know, caches and stuff like that. Right. Thank you very much, Graeme, for answering the questions. And I think we absolutely need to get you on camera next time for the second part. And thank you, Venkat, very much again and again for taking this time and being with us here. It was absolutely amazing. Deep appreciation. Thank you everyone for watching. Keep being active on socials, join the community, join the Slack channel for